We are going to continue from our last lesson where we looked at comparing fractions. But today we're going to have a look at using equivalence to help us compare fractions. So we have two different models here, and both of them are being used to compare 2/3 and 3/4. So have a look at these two methods. What's the same? What's different? So pause the video and have a little think. So you may have noticed that here we've got two wholes that are the same. We have split this top one into 3 parts. We've highlighted 2, so we have our 2/3. Then this one, we've got the same whole, but we've split it into 4 parts. We've shaded the 3, so we knew that we had 3/4. Now we can see quite easily that the 3/4 was bigger. So we could say that 3/4 is bigger than 2/3, which is great. But then you'll see this model over here is a little bit different. So we can still see that if we've split the shape here into 1, 2, 3 parts going down, so that would be 1, 2/3. So it's still 2/3. Oops. Still 2/3. And this one here, we can see we've split it into 1, 2, 3, 4 going across this time. And we've highlighted 3 of those. So that is still 3/4. But what do we notice that's different? Well, we split this one by 4 going across as well. So now you can see that each of these rectangles, so this rectangle here, is exactly the same as this one here. So using our equivalent fractions, which we used in a previous lesson, I could write that 2/3 is equivalent to 1, 2, 3, 4, 5, 6, 7, 8 over, and there are 12 squares in total, so I could say it's equivalent to 8 over 12. Now with my 3/4, I know I've got 3 there, 6, 9 twelfths. So I can see that 3/4 is bigger. Now looking here, I've got 8 twelfths and 9 twelfths. Well, what's the difference? Well, the difference between 8 twelfths and 9 twelfths is 1/12. So I know this is 1/12 bigger than this. So it means it allows us to compare the fractions, but a little bit more accurately. I can actually say how much bigger it is.